record. Okay, so let's begin. So initially, I would like to begin with some of the basic functions. Like in this case, I would define a square. So let's just first define like a square. At the rate square g equal to the rate cube. So here I would like to see the values of 3 square and 3 cube. So now I define the function. So the basic syntax of function starts by writing function, and then y is the output, and square is the function name, and x is our input. And then we define the actual function inside our syntax. So x square, and so here is the basic syntax for our square function. And then we are defining our cube function. P equal to cube. Cube. And now let's save it. And now let's run. So as you can see, we got our 3 square 9 and 3 cube 27. So this is a basic square and cube function. And now we'll dive into some of the more advanced functions. Like in this case, I would like to see I would like to see let's try our even or odd function. So in this case, I would define a function such that I would like to check whether our number is even or odd. So basically, our function would return like a would return like a string, which will say that whether our input is like odd or even. So let's see if mod y comma 2. Display and then else it is odd. So we have defined a function. So computes. So let's check whether checked even odd. Let's check whether 3 is odd. So as you can see, it is displaying that the number is odd. For some reason, I'm getting 0 as well. Why am I getting 0? Answer equal to 0. That's actually odd. It shouldn't return 0. Is there any mistake here? Let's check, and let's check it for even. check even odd for 8, suppose. So actually it is returning 1. For some reason it is odd. Okay. Okay, so there is something here. Check even. Okay, control this. Check even odd 6. For some reason it is returning 1, or that's fine.
Try say function 2 is named with the check even. So function name should be same
Acha,
as 5.
yes, I actually forgot that. Yes, save as करना चाहिए. सही बात है. Let's even odd. Check even odd 8. What is this? Incorrect use of equal to operator. Compare values for using equality. Function brackets. Check even odd 9. So now it is giving the correct response. So for 9 it is giving odd, and for 8 it is giving. Sorry, I just got rooted wrong. What are we at? So check even odd 8 even. So now it is correct. So let's move on. So now I would like to define a function like let's define like a function which returns up, which returns prime or not prime. So basically we would like to have a function which determines whether our number is actually a prime number, or it is not a prime number. So let's try to define such a function. Check prime. Count equal to 0. So in this case we are not, we have no output, we only have an input. So that's why we are defining this square bracket here. So let's define like a for loop, right? For true is true now. If modulus num comma count equal to display not prime. Break else if less than. Display prime. Let's save it. So in this case, what we did was that So basically every number would be a prime or a composite. So in this case, what we are trying to do is we are trying to take, because here we're defining our I from 2 to our number num. So basically we are not taking one, because one would give would give a erroneous value every time. So we are only taking it from 2 to num. And we could also define like one, because one is not prime or composite. So we can define another condition for that, but I'm not taking that now. So basically what we're trying to do is that for every modulus from num to I, we are checking that whether that number is like divisible or not. So we know that for prime number, it only has two factors, one and itself. So basically we are eliminating one, so that the only factor which is remaining is itself. So in that case, what happens that this modulus will only return zero, only return zero when when it is when it is a composite value, because for our for loop, it will take from 2 to num minus 1. So num will not be taken into consideration. So for every prime number there would be there the count will be restricted to 0. So in that case, it will only give us this else at the end of the loop, and it will give us prime number. But for a composite number, it will at least have one more factor. So so it will so it will increase to the count will the count will increase to 2, and it will eventually give us not prime. So like in this case, if we see check prime 9, check prime डिफाइन किया ना, इसको सेव नहीं किया क्या? कंट्रोल एस, invalid use of operator line 10. अच्छा ये दिस ठीक है, ओके कूल कूल. कंट्रोल, ओके कंट्रोल is check prime. So check prime 9. So 9 is giving us prime. No, count equal to 1 actually, right? Count equal to 1. check करते हैं. check prime 9. Yes. So basically 9 gave us not prime. So let's see if like 7 should be a prime, right? Oh yeah. CLC check prime 7. So it gave us prime. So like let's see if 13 is a prime number. Yes, 13 is giving a prime number. And like let's see, suppose 15. So 15 is not a prime number. So in this case, as we have successfully made a function which gives us prime or not a prime. You can also write in composite. So basically you have to use this if else and these for loops to essentially make a to essentially modify the solution towards your question. So that's how you basically use this for loops and these nested if loops in order to basically create our conditions. So basically we wrote our condition for like not prime, and then essentially if our I basically goes until num minus 1. So in that case, it will only trigger this else display prime. So that's why it is only giving us prime for numbers like 7, 13, and obviously 17 moving on. So let's check our let's check. So basically I would like to give you guys a simple function. Like so the question here would be, so in this case I would like to have like a function. So create a function. So create a function. So basically create a function in which we have to in which in which we are trying to determine whether a number x is a whether the number x is a factor of y or not. So essentially, in this case, we are taking in two inputs, y and x, and we are trying to create a function in which we determine whether x is a factor of y or it is not a factor of y. So I would like you guys to try it once in MATLAB, and in like 3 minutes I would like to give you my end of the solution. So there are like 21 participants.
Yeah, I think Vivek has some doubt.
Okay, Vivek.
No, it's clear. Yeah, please.
Okay, Vivek, would you like to speak out, or you would like to write in the chat box? That would also be fine.
Now it's clear.
Okay. Okay, cool. So basically the strength for today is 21 participants. Okay. Mhm. So I would take up the question at 24. So until then, you guys can try out the question. So is anybody has anybody tried this question? Basically no response.
If anybody has tried the question and facing any difficulty, he or she may ask Parikshit meanwhile the discussion session. You can ask, you can come up with your doubts and queries. So please participate in the session.
Please try to be a bit interactive. That makes the session quite like interactive and like quite lively for all of us, right? Otherwise it's like talking to a wall, right? Like nobody is responding whatsoever, so it becomes kind of boring. So okay, so let me give you guys the version that I created. Okay, let's see. Function equal to check factor if mod. So in this case, modulus is basically giving us the remainder between the y and x. So basically we are dividing x with y, and then it is giving us the remainder. So that is our mod function equal to 0. Let's display number is not okay. So let's see. So basically in this what I tried to do is that if the remainder comes out to be 0, then that number is the factor. So in that case, x is like the factor of y, and if the number is and 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 in every other case it will not be a factor basically. So let's see check factor. Let's see 13 comma 5. What happened? Line 7. It is yeah. बहुत गलती हो रही. Check factor. So let's see 7 comma 3. So in this case, it is giving us not a factor, which is obvious. So let's see if like 2 is a factor of 8. So it is actually a factor of 8. So likewise, you guys can like try out various functions in which you can like come up with a question and try to create functions in which you just modify the conditions in order for your question to work. So basically like you guys can like come up with all sorts of questions and create your own unique solution and have like fun with this. So now we are moving on to a new topic. So basically now I would like to start with function handles. So in this case, basically I would like to determine the values of like non-linear equations. So that's how this is how we define basically like a equation in X. So non-linear equation in X. So G equal to @ X cos X. So now we can see the values of f and g like this. And so basically we define this function handles in order to basically see that if there is like a very complex sort of an equation. So if we define it like this, we can essentially simplify them, like if we are trying to determine like suppose like f plus like f into g plus uh, fx into gx divided by brackets fx plus gx. So basically this thing, so in this case, as you can see, if we try to write this, like suppose not sin x, like suppose let's make it even lengthier, exponent x, and let's see, suppose this is minus exponent x. So if we try to download, so if we try to write this function, sorry, if we try to write this function in like in this basic form, like sin x plus exponential x into cos x minus exponential x divided by the sum, then it would be a very, very lengthy process. But if you but if you break it up into individual functions like this, and try to like write this into the into its basic form, then it actually becomes quite an easier task for everybody involved, and you can essentially check the value h3. So let's see, run. So as you can see, it is giving us the values 20.22 minus 21.50. So this thing would not be possible if we had like defined it in the like lengthy format. If you can actually like define it, but it becomes quite like an arduous task. So that's why we try to define it in the like in its breakup format. So now basically I would like to move on to into essentially some of the advanced stuff. So now I would like you to I would like to define the application of a very common toolbox. In this case, we are we are talking about symbolic math toolbox. So basically, symbolic math toolbox is like a set of, gives us a set of equations to solve. Sorry, gives us a set of solutions to solve our daily math equations. So in this case, CLC clear. CLC clear. So now we'll define sims. So sims is basically one of the tools of our symbolic math toolbox. Sims fx. Let's define fx to be sin x divided by x. So ddx. Potential f comma x. And let's also define the integral. Int f0.
Parikshit, tell them from where to install these toolboxes.
Okay, yes,
Otherwise, they will not.
yes, understand. So basically, toolboxes. So there are two ways to install toolboxes basically. So when you are first downloading it, then it will show you all the options for your toolbox. So in that, like download these 5 toolboxes: curve fitting toolbox, symbolic math toolbox, then our optimization toolbox, and then PD toolbox, and essentially what else? I think I'm forgetting one of the important ones. Repetition lineup, curve fitting PD modeler. So probably I'm forgetting something, but like these 4 are the major ones. So basically these 4 you need to like download it at the start of your installation. So basically when you're installing MATLAB from your like Chrome, so in there after your installation is complete, then in the and then in the installation tool, क्या बोलते हैं उसे, tool नहीं, installation interface, just take these four toolboxes at the start. But even if you haven't like installed it earlier, you can install it from like this. First you need to go to home, and then here you can see add-ons. So in the add-ons, get add-ons, right? Click to get add-ons. So in this one, there is it opens up our add-on explorer. So in the add-on explorer, if you like search, suppose symbolic mat toolbox, symbolic toolbox. So here you can see my symbolic mat toolbox is actually installed, right? So even if it is not installed, you can just like simply like go into, suppose I'm trying to go into RF toolbox, right? So just click it, and then as you can see, there's the option of installation. So just click install, and it will automatically install the toolbox into your MATLAB. So if you guys have installed MATLAB, so in that case you can try this add-on option, and then you can install your favorite toolboxes according to your own use. So let's see it. So now so basically DIFF is basically our differential, our differentiation of f with respect to x, and int is basically integration of f from the limits 0 to pi. And then let's check our value, double ddx. So double is basically like float. In this, basically it gives you the decimal up to a certain point, ddx. So not like integral, suppose like define it like integral f. So let's see downloads. So Control S, editor, run. So as you can see, it is giving us, so basically sin x by x. So basically the differentiation is cos x by x minus sin x by x squared, and then its integral value is sine of integral pi, and then we get our answers. So basically symbolic mat toolbox is our one of a kind toolbox. So with this we can basically do lots of our mathematics is maths sorry. So basically with this you can like try all kinds of things that math has to offer, right? So for differentiation you can try this out. You can, so for integration as well. So basically you can also like do indefinite integration, and like double integration, triple integration, and like all kinds of things. So now let's try something new. So now let's actually try. So like let's so now I will like give you the example. So in this case I would like you guys to basically just define a function. Basically, suppose cos y, cos y plus y square, suppose. So define a function cos y plus y square and try to get the and get the value and get the values and get the value of its of its differential at pi by 2 and its integral from 0 to pi 0 to pi. So I will give you guys like 4 minutes until 45 and just like give it a try and and if you and if you're able to get the solution, let me know in the chat box. Hmm. So guys, one तो मतलब एक सिंपल थिंग वन सिंपल थिंग तो मतलब बेसिकली अगर आपको मतलब कई मतलब कभी भी अगर मतलब दिक्कत हो रही हो किसी भी फंक्शन से, तो आप मतलब ये हेल्प एंड देन उस फंक्शन को लिख के आपको लाइक उसका उसका पूरा डेफिनेशन एंड एंड मतलब उसके उसके साथ में जो भी मतलब उसके कनेक्टेड एनोटेशंस आपको मिल जाएंगे. सो लाइक इन दिस केस कुछ लोगों ने कहा था कि सिंस सिंस आपको लाइक पता नहीं चला. सो इन दिस केस तो मतलब कि ये मतलब सिंबॉलिक वेरिएबल्स का लाइक शॉर्ट एनोटेशन था. सो अगर एग्जांपल हम देखें तो कहा गया. सो क्लियर सिंबॉलिक ऑब्जेक्ट्स एग्जांपल 2. तो सिम्स के बेसिकली मतलब बहुत सारे यूजेस है. हमने हमने इसका जो हमने इसका यूज किया बेसिकली टू टू डिफाइन इट्स डिफरेंशियल एंड इंटीग्रेशन. इसके और भी मतलब बहुत सारे यूजेस हैं एज यू कैन सी इन दिस एग्जांपल्स. So here in this case basically sims fx define करने से fx basically हमारा symbolic variable बन गया. So after इसको like उसका status मिल गया, then it is easier for it to get differentiated and essentially get integrated. So that is the use of our sims function here. So अभी 45 हो चुका है. So guys, like किसी का आंसर आया मतलब पिछले वाले क्वेश्चन का? Participants like so let's try this out. So let's see g of phi equal to ddy equal to differentiation g comma y. Integral g. What happened? से लेके पाई, फिर हमको डिफाइन करना है इसके वैल्यूज को डबल में. So in this case basically तो हमने यहाँ पर gy को डिफाइन किया cos y, तो हमने cos y plus y square लिया था, तो cos y plus y square. So basically हमने gy लिया था cos y plus y square, फिर हमने उसको डिफरेंशिएट किया तो 2y minus sin y बन गया. एंड आफ्टर दैट तो हम जब इसको इंटीग्रेट करते हैं तब ये मतलब ये पाई क्यूब बाई 3 ये उसी फॉर्मेट उसको उसी फॉर्मेट में उसने उसको छोड़ दिया. So essentially if we want to get the value in the decimal format, that's why we are writing it double. Otherwise if the answer is coming out in the decimal, then it is fine. But if you want to get it in, but if it is not coming it down in our decimal, then in that case you can write it in double or float and get the value. So control S. So now we'll move on to the ODE part. So ODE is like the heart of our MATLAB, right? So matlab even in all the courses that we have done, ODE is the one thing that is like common in all of them. So ordinary differential equation, it will be used everywhere. So learning a bit about ODE would go well in the long term. So now I would like to define like a couple ODE function y dot. So here y dot is essentially the derivative y dash coupled OD t comma y. Here t represents time, and y is our basic function y dot 2 comma 1. So global. So now one more thing. So global is basically it defines these variables as like the global variables that are applicable everywhere. So global means it is applicable throughout our screen. Equal to y of 1 2. So in this case, all these expressions are like not really that matlab like fixed. Everything is like volatile. So basically you can like change it up according to your own question. C into 1 minus 1 divided by t. So this question I think was one of our questions in our course. So these things would be like very useful in of course all your courses, and then it will also be used in like most of the projects that you will be undertaking. So again, matlab these things are like not really like fixed. You can like change these things up according to your question. So in this case, like we had like two derivatives, and that's why it is called like the coupled ODE. In this, like everything is interrelated. So like you have to define like side by side two derivatives which are like interconnected, and then try to find the solutions, and then try to find the solution using a coupled ODE. So let's define one more thing side by side. Yeah. So we defined it like this. So now we would like to plot this. Whatever we have defined, we would like to visualize this. So like let's put in some values. B, G, D, L, I. Suppose B equal to 0.15, G equal to 30, and T equal to 1.15. So here comes our OD45 function. So what is OD45? Let's see. Help OD45. So OD45 is used to basically solve all the non-stiff differential equations of the medium with the medium order method. So basically OD45, OD1, T-span Y0. So this is the basic syntax used for our OD45. Here OD1 represents our function, our like function to which we are deferring to, and T-span is basically the span of time until which you are trying to find a solution, and Y0 is the initial condition. So in this case, let's first save our function, Control S, coupled OD downloads. कहाँ गया coupled OD? Downloads. Okay, so basically here we'll defer to our function coupled OD, coupled OD, coupled OD. So after that we will define it. So our T span would be from 0 to 2 seconds, and suppose let our initial condition be from 0.7 to 1.0. So in this case, our initial condition is basically this C value, and so we'll try to like visualize our results. So what is happening? Star K, then T comma Y. So here we are like trying to plot like two things at once, side by side. Okay. Let our X label be time. So I think the plotting is covered in like pretty depth, like last session. So I don't think like I have to explain like each and every one of this. Plot X label, Soul Legend. Concentration, and then suppose let's say temperature in this case. Now let's save this, download. So in this case, it will be our ODE plot. Let's see. So here we ran it. So this is our plot. So in this case, as you can see, our concentration is increasing with time, but our temperature remains almost constant. So that is basically the crux of a coupled OD. So basically this coupled OD is used to like mostly solve all these like varying concentration questions in which we will have like three to four derivatives of our concentration, which will be like which will be varying with respect to all the four concentrations in like one thing. So like all of this is like interconnected, and that's why it is you can't like solve it individually, and that's why we need to couple this up and then solve it using OD45.
Hello.
Yes.
Actually, why after a coupled OD you write 02 and so you defined a why you use these things actually 02 and 071.
yes. So basically 02 is the time span. मतलब कि तुम कौन से टाइम से तुम स्टार्ट करके तुम कौन से टाइम तक जा रहे हो. मतलब मैं चाहूँ तो मैं 200 सेकेंड्स तक भी कर सकता हूँ, बट यूजुअली उतने टाइम तक मतलब रिएक्शन चलता नहीं है. मतलब because basically these things we do for reactions. So basically reaction में 1 से 2 सेकंड बहुत ज्यादा हो जाता है, like मिली सेकंड पे खत्म हो जाता है, उससे भी कम. तो दैट्स वाई लाइक ये टाइम स्पैन में इंटीग्रेट करना होता है, बिकॉज लाइक यहाँ पर मतलब आप एक पर्टिकुलर मोमेंट तक तो मतलब रिएक्शन चलेगा नहीं, राइट. तो मतलब वो मतलब एक पर्टिकुलर टाइम के बाद होता है खत्म. सो इसलिए उस पॉइंट तक हम लोग खींचते हैं, जिससे कि हमको उस पॉइंट पे जो कॉन्सेंट्रेशन जो है वो हमको मिले, राइट. तो दैट्स वाई लाइक जब हम लोग लाइक प्लॉट करते हैं, लाइक सपोज ये प्लॉट किया, तो ये बेसिकली ये वाला है टाइम, राइट. तो मतलब ये टाइम के साथ कैसे वेरिएशन हो रहा है ये हम देखने के लिए वो टाइम को 0 से 2 रखा है. तो आप देख सकते हो कि लाइक 2 सेकंड्स के बाद ये एसेंशियली स्टीप होते जा रहा है. तो मतलब ये अराउंड ये 0.85, ये अराउंड इसकी वैल्यू होगी कुछ अराउंड, इसकी वैल्यू क्या है, तो इसकी वैल्यू है अराउंड 0.87. तो कॉन्सेंट्रेशन 0.87 पे जाके मतलब स्टेबलाइज हो जा रहा है. तो उसको विजुलाइज करने के लिए हमको एक पर्टिकुलर टाइम लिमिट तक प्लॉट करना पड़ता है, जिससे कि हमको दिखे कि भाई इस पॉइंट पे वो लाइक पूरा स्टीप होते जा रहा है. एंड 0.7 टू 1.2 ये तो खाली वो इनिशियल कंडीशन सी है. तो सी को आप मतलब कुछ भी ले सकते हो, सी बेसिकली ये है रेट में. तो सी बेसिकली हम कुछ भी ले सकते हैं.
प्लॉट विजिबल नहीं है, तो पूरा स्क्रीन शेयर करना पड़ेगा.
ओके ओके ओके, तो न्यू शेयर करता हूँ स्क्रीन. सो मैंने स्क्रीन शेयर कर दिया फिर से. सो इज द प्लॉट विजिबल नाउ?
विजिबल.
Yes.
सो एज यू कैन सी मतलब ये 2 सेकेंड्स पे ये अराउंड स्टेबलाइज हो रहा है अराउंड एट 0.87, राइट. तो ये हमको विजुलाइज करने के लिए हमने 0 से 2 लिया. मतलब आप चाहो तो लाइक 0 से 3 भी ले सकते हो. Like suppose in this case we take 0 to 3, 1. So as you can see at 3 second it has like almost stabilized. मतलब ये इस पॉइंट के बाद ये कंसंट्रेशन इतना ही रहेगा, इससे ऊपर नहीं जाएगा. तो इसकी वैल्यू है 0.88, मतलब 0.8 like 0.889 पे स्टेबलाइज हो जाएगा. So that's why we take this time, but the initial condition C मतलब वो मतलब वेरी करता रहेगा, वो मतलब क्वेश्चन टू क्वेश्चन वेरी करता रहेगा. बट दैट इज लाइक अप टू मतलब अप टू द क्वेश्चन ईयर, या फिर मतलब अप टू द रिएक्शन कंडीशंस. ये हम बेसिकली कंट्रोल नहीं करते. एंड एंड एज फॉर द प्लॉट मतलब तुम प्लॉट में बेसिकली स्टार और ओ बेसिकली लिखने का ये मतलब होता है कि जिससे कि मतलब तुम डिफरेंशिएट कर पाओ कि मतलब कौन से तुम प्लॉट कर रहे हो. जैसे कि इन दिस केस हमने ओज रखे हैं जिससे कि वो हमको मिले टेम्परेचर, एंड स्टार रखा है फॉर आवर कॉन्सेंट्रेशन. तो ऐसे लाइक तुम डिफरेंट ले सकते हो. और एक्स लेवल वाई लेवल लेजेंड तो चलो ठीक है. एंड so that was it about the coupled OD, right? So now
लेजेंड के बारे में एक बार बोलिए.
okay, so basically प्लॉट एक बार दिखा देता हूँ ना प्लॉट. तो ये बेसिकली लेजेंड है कि नहीं, दिख रहा है. ये कंसंट्रेशन टेम्परेचर यही बेसिकली हमने डिफाइन किया लेजेंड में. लेजेंड कंसंट्रेशन टेम्परेचर, राइट. तो मतलब जब मतलब ग्राफ में बेसिकली आपको हर एक चीज दिखाना पड़ेगा, राइट. दैट्स व्हाई लाइक पूरा एकदम हमको समझ में आया कि भाई ये चीज कंसंट्रेशन है एंड ये चीज टेम्परेचर है, इसलिए हमने लेजेंड डिफाइन किया जिससे कि हमको ये दिखे. तो मतलब ये सारी की सारी चीजें आप प्लॉट को देख के मतलब विजुलाइज कर सकते हो कि अच्छा ये इसका ये इंपॉर्टेंस है, उसका वो इंपॉर्टेंस है. सो दैट सो दैट्स बेसिकली इट. मतलब ये जो कपल्ड ओडी है, कपल्ड ओडी का मतलब क्या होता है कि इसमें आपको लाइक मल्टीपल फाइल्स डिफाइन करनी पड़ेगी, और उसमें आपको लाइक एक से दूसरे में कनेक्ट करना पड़ेगा. जैसे कि इन दिस केस में कपल्ड ओडी को बुला रहा हूँ, और कपल्ड ओडी को ट्रिगर करते ही ये पूरा का पूरा चीज ट्रिगर हो जाएगा. फिर उसके बाद ये डेरिवेटिव लेता जाएगा और मतलब फॉर एवरी टाइम की वैल्यू ये डेरिवेटिव लेता जाएगा, और एक टाइम पॉइंट पे आके स्टॉप कर जाएगा. और उस टाइम पे जो भी कंसंट्रेशन आता है वो हम विजुलाइज करते हैं इसमें. सो दैट इज बेसिकली इट अबाउट कपल्ड ओडी. मतलब इससे भी फिर चीजें एडवांस होती हैं, बट लाइक मैं उतना डीप में अभी जाना नहीं चाहूंगा. सो हमने कहाँ तक डिफाइन किया था कपल्ड ओडी, राइट. Okay, so now let's move on to, so now let's try to move on to our F0 and F solve, right? So now we will try to define F0 and F solve. So एक बार मैं CLC कर दूं, CLC F0. So F0 basically single variable non-linear zero finding है. तो यहाँ पर हम क्या करेंगे, यहाँ पर हम फंक्शन, मतलब फंक्शन जो भी है अपना फंक्शन लिख देंगे, मतलब मोस्टली लाइक नॉन लीनियर फंक्शंस होंगे, एंड x0 इज आवर गेस वैल्यू, है ना. तो इसके गेस के अराउंड में जो भी इसका सोल्यूशन प्रेजेंट है वो इसको गेस करके फाइंड आउट करेगा एट द एब्सोल्यूट जीरो. तो likewise it will, you can like define it. So let's see, let's try out some examples. F0 and F solve. Let's see, suppose we define F to be cos x sin x plus x. So this is our function. So let's try to find out what is F0 at f comma 0, right? F comma 0. तो 0 is our guess value. तो इसके पास में कौन सा solution present है, right? So let's like save it. So let's see. So इसके पास में इसने solution लाया है -1.2587. So let's see if around, let's see like 4, है ना, 4 के पास में कुछ है solution. So 4 के अराउंड भी -1.2587 ही दे रहा है. तो मैं अगर नेगेटिव में चले जाऊँ -4, तो मतलब यही इसका एक सोल्यूशन है बेसिकली. सो दैट वे, मतलब बेसिकली तुमको लाइक अगर बहुत सारे तुमको, if you want all its solutions, so basically you can try all sorts of guess values, and then like see whether if it is giving the same one or a different one. That way you can essentially find out all its solutions. So there's like one more thing. So in this one we can also use it for F solve. So let's see what is F solve. Help F solve. So F solve also solves non-linear equations of several variables. So basically in F solve you can use like multiple variables but also basically F solve uses our a टॉलरेंस लिमिट. यानी कि मतलब मान के चल लो कि अगर फंक्शन एक्चुअली 0 नहीं बनता कभी भी, बट तो भी वो एक लाइक टॉलरेंस लिमिट तक वो सोल्यूशन फाइंड करेगा. जैसे कि इन दिस केस तो एफ सॉल्व हो रहा है, F0 हमको सेम ही वैल्यूज देंगे, राइट. इसमें मतलब वो डिफरेंट वैल्यूज नहीं देगा एफ सॉल्व. CLC. So in this case as well, F solve will give you the same solution. But suppose we try to define another function. Suppose we try to define like a g function, g@y. So suppose we define a monotonically increasing function which only becomes 0 at 0, like y square plus y की power 4. So it will only become 0 at y equal to 0, F0. But suppose we define like one of the like the 0.01, right? So in this case it will never become 0. So if we try to find the solution using G and like suppose 0.1, so let's see what will it give, right? Percentage. So as you can see, it is giving NaN, right? Which means it has no solution, right? It is giving like aborting search for an interval containing a sign change because NaN or NaN during search. So it has no solution, right? For absolute zero, it has no solution. But for the same case, if we solve it using fsolve 0, fsolve 0 point, suppose 0.001, not 0.001, right? In this case, let's see. So in this case, as you can see, our F0 is giving us NaN, right? So no solution available. But for fsolve it is giving us a solution visibly 2.3438 e ki power 10 ki power minus 0.5. So that is the basically like the crux of the difference between the two, right? Like it uses the tolerance limit. So there is a certain tolerance limit until which it finds the solution. After that also it will give no solution, but in this case it has triggered inside the tolerance limit. So that's why it is giving us this solution. But for f0 it checks whether the function gives us an absolute zero for any value of y, but in this case there is no y for which it will be zero. That's why it is giving us no solution. So that was it about our f0 fsolve. So f0 fsolve basically we use it for our like polynomial and non-linear functions, and like it will be, and mostly we try to use fsolve because like we deal with like massive decimals, so fsolve becomes much easier to use. And let's see, suppose now we will try to define so now we are so now I'll try to explore our optimization toolbox. So optimization toolbox, right? So basically what is our optimization toolbox, right? So let's see optimization toolbox. So basically, optimization toolbox provides functions for finding parameters with minimize or maximize objectives while satisfying constraints. The toolbox includes solvers for linear programming, mixed integer linear programming, MILP, quadratic programming, and then stuff. And so basically, like optimization toolbox, we like basically like it is used for like fine tuning the parameters so that we can like so that like we can solve the programming, we can use it to solve the linear programming, mixed integer linear programming for our non-linear equations to satisfy it for like maxima or its minima. So let's check it out. So in this case, suppose I define a function. So in this case, I will define a function in two variables, x and y. So let's see x. Suppose I define it like suppose x into exponent minus x square minus y square y square plus x square plus y square divided by 20. That's good. So now I will define a plotting function, namely f serve f comma brackets -2 select 2 and then show contours on one equal to @x, one equal to @x, x1 comma x2 x0 equal to brackets -5 -0.5. That is better. Like 0. Options, optimum options, f minus algorithm quasi-Newton and then options dot display equal to iter. Hello, if anybody is trying to speak up, then go ahead. F minus 1 x0 options. So basically in this case we defined our function, right? We defined our function and we are trying to visualize like what is its minima in like 3D, and then as you can see we are defining the options. So in this case we are defining the optimum options for its minima, and the algorithm we are trying to use is called the quasi-Newton. So algorithm is like whatever you can use, like whatever algorithm suits your taste. And then you can also like use maxima in place of this, and then options dot displays is your iteration, and then we are using it to display x and f value of its minima, fun x0 options. So it will be better if we try to like visualize it using the graph. So let's see. So let's just name it optimization toolbox. Control X. Okay, so let's run it. Okay, so it is actually giving us some warnings. So in this case, as you can see, all these contours, and let's see, we have our minima, and it is essentially like enunciating this minima, and of course there's a maxima as well. If we would have wanted, we could have also like enunciated the maxima in place of its minima, but here in this case we are doing it for our minima. So optimization toolbox is like useful for essentially like like finding the minima for very like difficult functions, and then doing like applying all sorts of algorithms on this to essentially get what we want. So so that's basically it for our session. So now we would be moving on towards the doubt session. So if anybody has any doubts, then go ahead and speak up. Hello Devanjan. Hello. Hello. Am I not audible?
Yeah, Parishit, you're audible.
Yeah,
Yeah, yeah.
yeah, yeah, Parikshit.
Okay. So that's basically it. Like at this point, like we can like go for like more examples, but I think like we have like covered like the basics of it at this point, because mostly we use at this point like the coupled OD and these toolboxes. And like later on if like in your projects you would be using some advanced things, those things would not be like counted in the basics. So you can like try to learn those advanced toolboxes on the run. So like that's what I did essentially. So that's basically it. But हाँ मतलब but one thing is that these basic function handles and the coupled OD, these two things are like very important for us chemical engineers, because like these things would be used like everywhere, almost everywhere. So that's like that's basically it. So guys, if you have like any doubts, just go ahead. CLC. Okay. Hello. Am I audible, right? I'm audible, right? Hello.
Yeah, Parikshit, you are audible.
Okay.
If
So
anybody is having any doubt, so he may ask Parikshit.
so first of all, I understand like it looks like very overwhelming. So even like when I started, it was very overwhelming like at the beginning. So basically like you guys have to just take it like step by step. So our motive for this MATLAB session was to just introduce you towards the various things that MATLAB has to offer. It is just the basics of it, but like if you have like, but obviously like you can't like master these things at the on the go, like at the beginning. But eventually like having a little bit of exposure at the start will help you give the direction in which you would like to move on in the future, and this will like really help you to essentially like master these things quite efficiently and quite speedily, right? So that was our basic motive. But of course I understand that it is like very like like overwhelming. So like if you guys have any doubts, like feel free to ask me. You like if you guys like if anybody has any difficulty in speaking, then he can also like write it in the chat box. show counters optim options. Let's see. Help optim options. So basically optim options is like, it is to like create or like modify optimization options. So in this case, like we defined, like it creates all these optimization options with the option parameters set to default values relevant to our solver. For example, f min point for a list of valid optimization solvers, entered doc optim option to obtain the, ये सब थोड़ा ज़्यादा हो गया. हाँ. So like, so in this case, we only like define the algorithm quasi Newton. You can also like define define the tolerance value, and if you want, like you can display iteration in the options itself. But basically, like it has no like particular order, right? After like algorithm quasi Newton, you can also write the tolerance value, and essentially it is these options are used to essentially like modify our modify our our graph according to our needs, right? Like whatever problem statement that you have, you can just use it to modify our, you just have to like modify the options, and then your answer comes in, right? So what is show counter, right? So let's see. CLC help show counters. So basically it displays the counter plot under the plot. If you see its documentation, where is the counter plot? Show counter. Yeah. So display counter plot under plot specified as on or off. Numerical a value of on is equal to 2 and off is equal to this. You can use. So it is basically used to plot this contour plot. So in this case, when we run it, as you can see, this plot, this whole plot in which like you can see all these vibrations beneath, this is called the counter plot. So in this case, we want the counter plot, and that's why we are writing show counter, and then essentially we are writing on so that it is actually visible. Like if you write off, suppose we write off, then CLC control S. So in this case, as you can see, there are no vibrations, right? So in this case, there are no vibrations. So that is the effect of counter, having a counter or not. Basically, like these counter plots, I think would be like very useful in mapping like earthquakes and all these like calamities, right? So having all those epicenters and stuff. So like this is very useful in like doing all those kind of things. So let's just make it on Control S. So let's see, there is one more doubt. Show the counter. Yeah. Yes. So if anybody else has a doubt, please feel free to come up. CLC. Okay, so anybody else has a doubt?
If there is nothing, Prashit, then maybe we can in this.
Okay, so I'll wait for 5 more minutes. If anybody has a doubt, feel free to write it in the chat box or like speak up. Or if not, then I think that would be it, right? So at 16:35, if there is like no response, then I think it would be safe to assume that we would like to like end the session at that.